Internal parasites have been identified as the highest cost disease of sheep and cattle in Australasia. Recent studies attribute losses in the tens of billions worldwide, with estimated losses of $1 billion for Australian producers and $700 million for New Zealand producers. In 2015 alone, financial losses due to internal parasites in Australia were estimated at a staggering $436 million for sheep producers, $94 million for cattle producers, and more than $2.5 million for goat producers. Since then, these costs have continued to increase. The selected strain of Duddingtonia flagrans is a natural fungus isolated from pasture and was one of 25 strains found as part of a field survey of nematophagous fungi in Australia by the CSIRO in 1992-93. International Animal Health began its collaboration with the CSIRO in December 1997 before assuming the overall commercialisation role in 2004. The preferred strain became IAH 1297. Globally, Duddingtonia flagrans has widespread natural occurrence and low genetic variation, meaning it is similar all around the world. It is highly host-specific for parasites of grazing animals. It colonizes the fecal pats, with surrounding soil rarely colonized. It has no effects on other non-target organisms like insects, earthworms, dung beetles, soil nematodes, soil fungi, or microfauna. It cannot become infective or toxic in warm-blooded animals as the spores do not germinate at 37 degrees or under anaerobic conditions. Duddingtonia flagrans is a nematophagous fungus, meaning that it traps, paralyzes, and consumes nematodes. It is a non-chemical biological control for the free-living stages of parasitic gastrointestinal nematodes of grazing animals, which acts by substantially reducing the numbers of infective worm larvae, including multi-resistant larvae, emerging from manure onto pasture. BioWorma is fed to grazing animals. The thick-walled spores remain inert, having no effect within the host animal, resisting digestion and passing through into the manure. There they germinate and form, trapping organs that capture, paralyze and consume emerging infective worm larvae, including multi-resistant larvae. The crucial reinfestation stage of the parasite's life cycle is interrupted, reducing the amount of reinfection from contaminated pasture. This interruption of the life cycle significantly reduces parasitic nematodes on pasture. To administer, Step 1. Complete fecal egg count. Step 2. For best results, treat animals with a suitable chemical wormer. Step 3. Where possible, move the treated animals onto clean pasture. Step 4. Commence daily feeding of BioWorma to minimise pasture infectivity and maintain the animal's low worm status. Step 5. Use in conjunction with a recommended worm control program for your area. Contact your veterinarian or state or local worm control coordinator for strategic integrated parasite management. Australian field trials have shown significant reductions in pasture infectivity in sheep, cattle, goats, and horses in different climatic zones and seasons, with similar results in zoo animals. BioWorma targets a variety of nematodes, including, for sheep, goats and cattle, Barber's poleworm or wireworm, black scourworm, small brown stomach worm, medium brown stomach worm, nodule worm, hairworm, intestinal worm, thin-necked intestinal worm, and hookworm. While for horses, redworms or large strongyles and small strongyles. It's also proven to target nematodes of other grazing animals, such as deer, alpacas, zoo animals, and many more. Our initial target had been 50% reduction on infected pasture. Efficacy trials in cattle, horses and goats over a 5-year period showed reductions from 53 to 99%, with an overall average of 78%, while in sheep, the reduction ranged from 57 to 75%, with an overall reduction of 68%. These include multi-resistant parasites. Safety studies were addressed, with long-term feeding tolerance studies at up to 10 times the intended dose level in sheep, cattle, and horses. Safety studies were also conducted on laboratory animals to obtain information on the possible toxicity for humans, both consumers and workers, when applying the feed additive. The studies concluded that there are no safety concerns from exposure to BioWorma for treated animals, farm workers, manufacturing workers, or consumers. Studies in animals treated with BioWorma, IAH 1297, were not required, as it was shown that maximum residue intake levels in animals and consumers are below the established European Food Safety Authority limit. The extent of resistance to anthelmintics is best documented in production animals, and a survey of sheep in Australia found widespread resistance in all common sheep parasites and broad-spectrum anthelmintics. Similarly, the FAO has reported resistance and multi-resistance in sheep, goats, and cattle.